Okay, good afternoon, everyone. Thanks for attending this presentation. Hope everyone had a good summer. Today we are going to talk about how to achieve best results in your deep hole drilling applications. Okay. Absolute Machine Tools is our exclusive importer and distributor for machine tools in the US market. Precihole specializes in manufacturing of deep hole drilling and hole finishing solutions. And we have been serving the industry since 1988, so we've been around for a while. Okay. The agenda for today is going to be, we're going to present some facts on deep hole drilling. Then we'll look at some of the fundamentals of deep hole drilling, what it is, how to get it done, the apparatus for that. Then we'll look at some of the output parameters of how do you measure deep hole drilling, what is success in deep hole drilling. Then we will focus the presentation on really our knowledge. We have been around for a while. We have made machines for hundreds of deep hole drilling applications. So we have put together all our thoughts, all our knowledge in these tips and tricks that we present to you. And then we'll look at some real-world applications for deep hole drilling. You will see simulations of the real-world applications, and then we'll present some of the solutions that we have. Okay? So let's get started. Myths or facts, you decide. Okay? Gun drilling is a very difficult and expensive operation to bring in-house. This is a general trend, general thought in people's mind. Not really true. Gun drilling is really a very repeatable and consistent process. It really offers process reliability. Selection of a proper machine tool is very important, tooling as well. And once you have set all these parameters in place, it really becomes a push-button operation for the operator to do. So really, gun drilling is nothing to be scared about. Deep hole drilling is nothing to be scared about. If you set it right, it produces the right results. The second fact is very high product volumes are required for gun drilling. Again, not really true. Gun drilling machines today offer quick change mechanisms for tool and component change that really eliminate the need for long setup and changeovers. So you can really have a small or medium batch that you can successfully do on a gun drilling or deep hole drilling machine. Okay. I've been asked this question multiple times while talking to customers. Gun drilling can only be used for drilling gun barrels, And the answer is not true again. Although gun drilling originated in the First World War and proved to be one of the best ways to make gun barrels, today it has been really applied in many, many, many applications, hundreds of applications in 30-plus industries. And the list of applications is just growing. Many tool manufacturers, machine manufacturers like us are really pushing the technology to where it has never been before. So many, many applications today are being covered by deep hole drilling than before. With all the advances in technology that we have today, gun drilling produces perfectly straight holes. You wish. There are many special applications where the length to diameter ratios are 400:1 or even more. And obviously, you would expect some loss of straightness or drift in the application. That's very natural, The general rule of thumb is really 4 thou per, 100 millimeters or 4 inches. But that's the knowledge that I'm going to give you today. So if you listen to me very carefully, you can probably improve this much further. Okay. The next one is building a gun drilling machine is so easy, I can build one in my garage, right? No, really not. Mastering gun drilling technology really takes a lot of expertise. It takes years of experience. And you really need to know some fundamentals. You really need to know the accuracies. You really need to know the features that go into building these machines for special applications. And to really get everything assembled together, check the accuracies at the right places to build or to bring all this together. And really, that's why there are only so many that can really build a good gun drilling machine, And we in the gun drilling or deep hole drilling industry respect each other. All the competitors really respect each other because we know what pains we go through while building these machines and getting this technology to work. Okay. Another thing is nothing has changed in the gun drilling or deep hole drilling industry for a very long time. And the answer is not true. Electromechanical systems, really ball screw, use of ball screw or rack and pinion systems that give infinitely variable feed rates, use of CNC controls, linear motion guideways, electronic sensors. Everything on the machine is today monitored and controlled, and you can have very precise monitoring and control of these feeds, speeds, etc. on the machine. You have tool monitoring systems that prevent tool from breaking. Some of these tools and components are very, very expensive. So there are tool monitoring systems on these machines that prevent breakup of these things. The tooling design, the materials that are used, and the geometry of tooling has changed a lot. Today you can push the machine tool, and I'm going to give you some examples in the rest of the presentation, but today tooling design has really changed dramatically that really pushes gun drilling technology to a new edge. Okay. Even coolant oils that are used, the additives that you add to coolant oils and filtration systems have gone through a sea of change that really enhance deep hole drilling technology a lot. Okay. And we are going to talk about all these in the rest of the presentation. So, deep hole drilling technology, the major applications, although it finds applications in many industries, the major applications of deep hole drilling really are defense, firearms, oil and gas, aerospace, energy, nuclear, solar, wind, die and mold, medical implants, all your bone screws and cannulated nails and drills, automotive, obviously, there are probably hundreds of applications within automotive itself that find their way. And then hydraulic cylinders. You have skiving roller burnishing machines that do hydraulic cylinders. So this is essentially the gamut of where most applications are found for deep hole drilling technology. Let's take a look at deep hole drilling fundamentals. Okay. Essentially, when you have conventional drilling, your normal HSS twist drills, really the length to diameter ratios that you can achieve are not much, 5:1, 7:1, etc. You can get slightly more by use of basically peck drilling and getting your chips out. You can go slightly deeper, maybe 10:1 or slightly more than that. You can also have coolant through twist drills that can help in this. But really, when your holes get really deeper, a lot of issues like tool life, surface finish, roughness, hole straightness, chip removal become a problem. Okay? And that's exactly where deep hole drilling technology or use of deep hole drilling technology comes up. So what is a deep hole? How do you define a deep hole? So by definition, wherever the length to diameter ratio is more than 10, that hole is defined as a deep hole. Okay? The different configurations that you have for deep hole drilling are really, the first one is where the tool is rotating and the component is stationary. Okay? This is used for asymmetric parts where you have off-center holes in these cases. The second one is where the part is rotating and the tool is stationary and feeding. Okay? This is used for really round parts with central holes. And the third one is where the tool is rotating and the part is counter-rotating. Okay? And this is what really gives a very good hole, a very straight hole, and this is used where really the holes need to be really precise and more accurate than the previous configuration. Okay? And this is obviously more expensive because you're counter-rotating the part, so the setup for counter-rotation, the steadies, etc., obviously grow. So the machines are more expensive, but still this is a better technology to use if you can. Okay? So let's define the types of deep hole drilling. Okay? And predominantly there are two types, gun drilling and BTA drilling. Now BTA drilling also has a variation which is ejector drilling, but for all your small holes you would use gun drilling. Okay? That is usually from about 0.04 inches to about 1.5 inches. In this particular one, in gun drilling, you have high pressure coolant that is fed through the drill, and the chips and the swarf oil, they come out from the cavity of the gun drill. So that's the technology that is used. For larger diameters, you have BTA, which is the Boring and Trepanning Association, or the single tube system. That's used, and that's predominantly from 0.5 inch to about 16 inches or even more. The coolant is fed over, and we'll take a look at the apparatus that is used for this, but the coolant is fed over the tube, and then the chips, because of the cutting action, the chips and the coolant come within the tube, and they are flushed out from the back. Okay? The ejector system is a variation of BTA, predominantly where instead of using just one tube, you have two tubes. So the oil is fed from behind, from the outer tube, and then the chips and the coolant are taken from the inner tube, so inside the inner tube. Okay? Let's take a look at the gun drilling process itself, the apparatus that is used for gun drilling. Okay? So you have a component that is held in a cone or a chuck. There is a chip box or a bush box from which the chips are taken out. The gun drill comes from behind. The coolant is fed through within the gun drill, and the chips are taken out as the red arrow shows. Okay? So this is the general apparatus of how gun drilling takes place. The design of the gun drill, essentially, as you can see on the side, is it consists of three parts. The outer part is the carbide lug, which is brazed on to a tube, to a long tube, and then there is a driver that gets inserted into the spindle. So this is the design of the gun drill. The coolant comes from within, and then the chips and the swarf come from outside this kidney-shaped cavity. Okay? Let's take a look at it one more time. Let's take a look at the BTA drilling. So for larger diameters, as I said, you have the BTA process where you have the component that is again held in a cone or a chuck, and then you have a pressure head from which the high pressure oil is put into the system, and the drilling action takes place, and the chips and coolant are fed from behind. From the tube they go back and are evacuated. So this is the arrangement for the BTA drilling process. Now let's take a quick look at some of the output measures in deep hole drilling. Really, this is what defines success. How do you measure deep hole drilling? Okay. And there are three critical parameters, and we'll focus the rest of the presentation in really ensuring how to get the best output for these particular parameters. And the first one is really hole straightness. The second one is hole tolerance, and the third one is hole surface finish. Okay? So if you can control these three parameters, you have success in your deep hole drilling application. How do you define hole straightness? Hole straightness is really defined as the maximum deviation for the hole compared to the center line. Okay? And you have a lot of factors that really affect your hole straightness. The configuration of the gun drilling setup, as we said, there are 3 setups, and the counter-rotating setup is the one that really gives you the best results. Guide bush design and accuracy. We're going to talk a lot about guide bush for the process in the coming slides. The tool and insert condition, the tool geometry, the angles that you have, the tapers that you have, the input condition of the component itself, how well is it faced, how well is it chamfered, the material itself. The material in deep hole drilling is very, 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 very important. If you have good quality material that is homogeneous, that is, the hardness of the material is even throughout, you have very good results. Okay. The coolant, the type of coolant, the pressure of the coolant, the additives that are added to a coolant, the tube and tool support. You have 40 and 60 feet jobs that you do in deep hole drilling. You need to support the tubes that go for drilling as well as the job itself. So we'll talk about, what kind of support do you need, how much, at what length to diameter ratios you need to support. And then the machine condition and alignment itself. So if you have a newer machine, if you have been using a machine that is 40, 50 years old compared to what exists today, obviously you're going to get better results because the technology has changed. Okay. Hole tolerance. The second factor to measure in deep hole drilling is hole tolerance. Tolerance is really the allowable variation for any given size. It's basically the difference between the minimum and the maximum that is allowable, right? And the factors that affect hole tolerance, obviously there are some common factors, but we'll discuss these factors, in the remaining slides. But these are the different factors that affect hole tolerance. Okay. And the third one is really surface finish. Surface finish, again, is a measure of the texture or the roughness of the surface. And there are many factors, as you can see, that affect your surface finish. Okay. Obviously, deep hole drilling or gun drilling can give you a certain range of surface finish. And if this process is not enough, then you have hole finishing processes that you can use, like honing, reaming, lapping, etc. That also skiving and roller burnishing that you apply to get even better surface finish. Okay. Now that we have understood the fundamentals of deep hole drilling, we'll really try to go over some of the tips and tricks on how to achieve best results. Okay. The first one is the machine tool itself. Okay. Selection of the machine tool, selection of a specially designed machine tool that is designed for the process really results in good results, right? The machine base that we design for this is capable of handling the loads that come. If you're drilling really 10 inches, 5 inches more, there is a lot of load on the machines. The machine base has to be able to withstand that kind of load and to create good dampening characteristics for the process. Okay? Use of high-speed drilling spindles, the motors that are used, the high-torque motors that are used on the machines, high-pressure coolant filtration systems, filtration coolant, the amount of coolant that you need to evacuate the chips, and the kind of coolant pressure system, the high-pressure system that you need on the machine makes it very unique. It makes it absolutely necessary for you to have a good high-pressure coolant filtration system to be able to get success from your application. As I said, tool monitoring systems really prevent the tool from, breaking and, really causing big trouble for you. Also, the tube guiding and vibrational dampening is very, very effective on a dedicated deep hole drilling machine. Okay. The second one is really appropriate selection of the deep hole drilling setup. So if you have precise and accurate holes that you need, you need to be able to really, you need to be able to choose the right process for your application, okay? And as you can see in the simulation, if you have counter rotation where the drilling takes place, you get much straighter holes, much better results in depot drilling. So essentially, counter rotation of the part creates a straighter axis and keeps the gun drill in the center while the drilling takes place. Okay, so that's why for cylindrical parts, for shaft-like parts, we highly recommend use of counter rotation during the process. Okay, and this is the difference. Just a simple example: while drilling gun barrels, you have a 5.56 millimeter gun barrel at 530 RPM. You can see that if you drill 28 inches, you have 3 to 5 thou of drift if you have counter rotation. If you don't use counter rotation, that drift could be 0.02 to 0.8, which is really 6 times of what you can get. So if you have slender jobs, long jobs which really require precise and accurate holes, counter rotation really makes a big difference. Okay. The next very, very important factor is really the guide bush. Okay. So the bushing, guide bush is an accessory that really guides the drill into the part, essentially, when the drilling process starts. Okay? And this particular guide bush is a very, very, very critical factor, because if you don't have good matching, then the drilling starts bad, and what starts bad really cannot end good. Okay? So essentially, a guide bush is a very, very important accessory to have in depot drilling. Okay. Some additional notes on the guide bush, since it's that important. Really make sure that the guide bush and the gun drill are matched prior to use. So essentially, that's one of the best practices. You cannot have any play between the guide bush and the gun drill. It needs to be manually matched for best results. Any play in that results in bell mouthing of the start of the hole. And really, once that gets bad, very difficult to correct it later. Okay, so it also the guiding length, the length of the guide bush is very, very important. It needs to make sure that the gun drill, when it starts, it has enough support when it enters the component at the start when the drilling takes place. Okay, the manufacturing tolerances. We manufacture guide bushes, but we spent, I think, the most amount of time in manufacturing of the guide bush rather than any other part of the machine, because it's so important. Okay, so the manufacturing tolerances on these guide bushes, whether you are doing gun drilling or BTA, is very, very important. Okay, hardness of the guide bush also is critical, because if you don't have enough hardness, it's going to wear out very soon, and you'll have to replace it. So what starts good ends great. So, that's the general rule for guide bushes. It's a very, very important factor in depot drilling. Okay. The next one is obviously the tool or insert selection for your depot drilling. Okay. And essentially, many tool manufacturers give a wide range of, speeds, feeds, coolant pressures. So they give you, recommendations on your application, but those particular recommendations really need to be fine-tuned. So selection of the right tool. If you have harder materials, you need to have a coating on your tool. It's very, very important to be able to successfully drill harder materials. The carbide, the grade of the carbide that is used in drilling, very, very important. Then the configuration of the support pads for gun drills or for BTA cutters. So there is a lot of choice that tool manufacturers offer you for your applications, but selection of this is very, very important, because if you choose the right tool, it makes a big difference in your output results. Okay. If you choose the right tool, but if your insert or tool condition is not good, causes a problem. So you need to make sure that your gun drill is sharp, it is ground properly at regular intervals. If you are drilling exotic materials, hardened materials, you have to drill your edge, you have to regrind your edge more frequently. But a chipped off drill or a blunt edge really causes a lot of problem in your application. It really gives you bad results and causes a lot of trouble. Okay? If you're drilling very long parts, 20 feet, 40 feet, 60 feet parts, obviously you might have to make intermittent checks for tool or insert condition, because you need to check that maybe one insert is not enough to go through the entire part. So you might have to stop it, bring it back, change the insert, and then restart drilling. Okay? The next factor that we talk about is the coolant pressure. Okay? Pumping the coolant at the right pressure really helps to evacuate the chips properly, efficiently. It also takes the heat, because this particular operation generates a lot of heat in the process. So it helps to take off that heat, and it also helps lubrication of your guide pads on the process. So really pumping the oil at the right pressure, so having a coolant filtration system that can pump in the optimum amount of, or that can generate optimum amount of pressure for your application is very, very important. Okay? Really your straightness and bore tolerance are pretty much affected by the, by the pressure of oil. This is just a general, chart of as the size of drilling increases, the coolant pressure requirement reduces. Just a chart to show you at what pressure you need to filter. And this is very common information. A lot of tool manufacturers also have this recommendation, presented. The next most important thing is really the coolant type. Okay, you cannot just use ordinary oil for your depot drilling application. So you really need to use a special coolant, a special gun drilling oil for your depot drilling applications. Okay? And this particular oil is a straight cutting oil with very low viscosity of 10 to 12 centistokes at 100 Fahrenheit. Okay? Also, these oils need to have extreme pressure additives added to those, like a little 2 to 2.5% sulfur or 4 to 4.5% chlorine really helps improve the process. Also, these oils need to have anti-foaming properties to really be able to successfully drill. Okay? So we highly recommend using specially formulated gun drill oils only rather than using just neat cutting oils. And water-soluble oils are sometimes used for cast iron material. Okay? The next one is coolant temperature. Okay? Coolant, obviously, it's a recirculating mechanism for this particular oil. You need to use an oil chiller to really maintain the temperature at around 100 Fahrenheit or below to make sure that the process is good. So this particular removing the process heat really improves your tool life and also gives you good tolerance and surface finish on your holes. Okay, so all our machines, whether gun drilling or BTA, come with refrigerating systems for oil. Okay, very, very important. The next factor that we look at is essentially machine accuracy and alignment of moving elements. Okay, it is, if you really need good results, you need to make sure that from one end of your drilling, that is your tool spindles, your tool steadies, your bush box or your chip box, your component steadies, and your component work heads are all aligned perfectly in one axis. Okay? It is very, very important for a machine manufacturer to ensure that they give you a machine that has all these things in a perfect axis. So we do spend, when we make machines, we do spend significant amounts of time in ensuring that really all these components fit well and they are perfectly aligned so that the final results are accurate on the machine. Okay? So that is very, very, sometimes these things go out of alignment, and we recommend periodic check of these, of alignment on the machine to make sure that you're getting good results. Because you could be doing everything right, but if you don't do, if the alignment is out of whack, then obviously you're going to have trouble. Okay. The next one is the cutting parameter selection. In order to obtain good results, you need to make sure that the recommendations from tooling manufacturers are taken, and really these are fine-tuned to your application. Basically, you can't just take those recommendations and follow them, because there is so much of variation in your particular application, the material, the size, the machine that you're drilling, the RPM, everything. You need to make sure that you are fine-tuning them for a production mode on your application. Okay, so that's cutting parameter selection. The next one is tube support and guiding mechanisms. Okay, the tubes that are used in gun drilling or deep hole drilling are very, very long. They need to be supported at intermittent intervals so that the process is successful. And our recommendation is really the guiding needs to be every 30 to 40 length to diameter ratios to be successful. Okay, so that's where you need either a whip guide in case of gun drilling, or a tool steady that really holds the tube in place, or in case of BTA, it's called as a vibration dampener every 30 to 40 length to diameter ratios for a successful drilling. If it causes whipping of the tube, it really causes damage, and inaccuracy in the component. Okay. The next factor is the material itself. Okay, and this is a major factor that contributes to success of your gun drilling or deep hole drilling application. Essentially, any hard spots in the material or uneven grain structure really causes a lot of damage, because the carbide that is used for drilling really is brittle. So if it encounters a hard spot, it really causes chipping or breakage, and then the whole process goes astray. So it is very important for you to buy material from good sources and have uniform heat treatment of the material for success. Okay. The last but not least factor is really coolant filtration. Okay. The filtration that is used on the machine really to remove your chips or to remove the fine powder that is generated from deep hole drilling really ensures that your drill life, your gun drill life is extended, and really your hole tolerance and surface finish are good in the application. Okay, so it's absolutely essential for you to filter this oil by using a right filtration system on the machine. Okay. Also, your high pressure coolant pumps, which are very expensive accessories, or your coolant unions, the life of these is very much dependent on the quality of filtration, because they don't like impurities getting in and they cause a lot of trouble. So make sure that your coolant filtration system is ideal and it's purifying the oil to the right amount. And different applications require different levels of filtration. This is just a summary of all the factors that we discussed and how they affect straightness, tolerance, and surface finish. Okay, just gives you, you have handouts, you have a copy of these. I'm not going to go through each one of them, but this is how each factor really contributes to success of straightness, tolerance, and surface finish. Now let's take a look at some of the real-world applications in different industries in terms of how how this application takes place. We also have, these are case studies that we have really gone through, that we have really proved. So the output factors, the cutting parameters as well as output factors are mentioned as well. So the first one is really in the medical implant industry. You have bone screws, and you will see how the bone screws, how many spindles, how much it can affect. So it's essentially a 2-spindle configuration for the bone screws. The bone screws are held on approximate loaders, and they go in cones. Okay, they are held automatically. The clamping takes place. This is just a configuration of the gun drilling setup. The gun drill comes in. So this is the, in the medical implant industry, these are bone screws being drilled, okay? And the material is titanium or stainless steel, are the best materials to drill. The next one is in the automotive sector. You have connecting rods that need to get drilled. This is actually an angular application. So the design of the guide bush, the butting of the guide bush to the component are really critical. And you will see how the drilling takes place. So you have the angular guide bush that butts against the component, and then the drilling starts. Okay, so this is essentially angular drilling, using a fixture on the table. Application is a shock absorber, where really you are counter boring and finishing the thing, not just gun drilling. So it's essentially the hole already exists that you are trying to enlarge and finish. It's also an automotive application. So you will see the setup. These are the inside of the pressure head and guide bush. The drilling tool coming in and trying to finish the enlarge and finish the hole. The components are rotated, the cutting tool comes in and bores the component. And you can see the production rate is about 100 an hour for these components. Okay. The next one is one of the favorite in the gun drilling industry, which is gun barrels. Very, very common application. These are your AR-15 barrels, essentially. The material can be 4140, 4150, SS416R. We have a 4-spindle machine for drilling this for high volumes of gun barrels. And the feed rates are about 7 or 8 inches per minute. And this produces about 50 barrels an hour with very, very good straightness, surface finish, and hole tolerance. The next one is a XY type of application, where you have multiple holes that need to get drilled on one setup, And the best example is the glass molds, which have about 100 holes, 90 to 100 holes that get drilled. The production or the volume requirement of this industry is such that we need to provide a multi-spindle machine, 1, 2, or 4 spindles for drilling these holes. Okay. So multiple holes get drilled in just one setup, and they are very, very accurate, very fine holes in cast iron or brass. In this application. So you can see the gun drill comes and drills the first hole, then the table indexes by itself, locating the next hole for the application, and then it drills the next hole. So you can pretty much, using this type of setup, you can drill hundreds of holes in one part in just one setup. The last one is a cylinder housing, in which we are going to do, I'm going to show you PTA drilling. We covered a lot of gun drilling applications, but for PTA drilling is where it's about 4 inches hole. The component is located back in the chuck. Steady vibrational damp. This is the inside of the pressure head and guide bush. So these were some real-world examples of how the drilling takes place, what are the cutting parameters, what are the output parameters that you can get. Now let's take a quick look at machine tool solutions that precihole offers. Predominantly, the machine tools that we offer are divided into 3 parts. The deep hole drilling machines. You have single-axis gun drilling machines, multi-axis deep hole drilling machines, BTA drilling machines, multi-axis BTA drilling machines, ejector drilling machines. Then you have hole finishing machines, which are skiving and roller burnishing machines, honing machines, pull reaming machines, and lapping machines. And then we have custom designed special purpose machines that suit your applications. Really highly customized deep hole drilling machines that are really designed and suited for your applications. Facing and chamfering machines, broaching and rifling machines, for all small as well as large bore calibers. And then you have boring machines. Okay. Our gun drilling machines this is the world premiere that we have at IMTS for the micro gun drilling machine. Really, it's suited for the medical industry, but really, in fact, any any small hole from 1 millimeter to 6 millimeters up to a foot long, up to 12 inches can be done on this machine. Okay, and we are providing 2 spindle configuration. It comes in 1 or 2 spindles. It has ultra high speed motorized spindles, coolant pressures to 2300 psi. 1 or 2 spindles, as I said, 24,000 RPM on the spindles. Tool monitoring system already built into the system. So and a very, very compact footprint. It's more like a tabletop design. And these are just some pictures of our micro drilling. We are in S8536 in the South Hall. You can come and visit us. But this is the machine that we are really premiering at the show. So the world premiere, this is the first time we are introducing this machine. It's already proven. We are introducing this machine here at the show. Okay. Our workhorse is really the single-axis gun drilling machines. We make most of them in the year. Really, applications are in firearms, gun barrels, automotive. A lot of applications in automotive instrumentation as well. And these come in 1, 2, or 4 spindles, and they are it comes in at 24 inches, 30 inches, 40 inches, 60 inches length. Okay, so these are essentially single-axis gun drilling machines with PLC or CNC controls that we make. Okay, The next one is a 3-axis gun drilling machine with a XY motion. So this has a knee-type structure in which the table moves up and down, giving the X and Y, and the drilling is a Z-axis. Okay, so we give this machine in 1 or 2 spindles, and this is for industries that require multiple holes to be drilled in the same setup. So you can drill really hundreds of holes in just one setup using this type of machine. Okay. The next one is a multi-axis gun drilling, or BTA. Really, this goes from 3-axis to 9-axis CNC, and this has a very large table for really components like mold bases and stuff, where it can have rotary axis, the B axis, the A axis, the angular motions, the Z axis. We also provide secondary spindles for drilling, tapping, milling, etc. So this is these are some of the bigger machines that we provide. For larger components. And again, in this particular one, you can drill multiple holes in the same setup. Okay. For the larger size, we have of course, the BTA drilling machines. For larger holes, longer holes. Especially suited for your artillery barrels or aerospace landing gear shafts or oil and gas. A lot of applications in the oil and gas industry for these type of machines. Also energy. Okay. And these are some pictures of our BTA drilling machines. In general, this is just a quick collage of all the larger shaft type components that are drilled on the BTA drilling machines. Okay, for oil and gas, aerospace, energy, and defense. Okay. So essentially, we are deep hole drilling and hole finishing specialists. We are in hall S8536 at the Absolute Machine Tools stall. Please visit us if you have any applications that you need to discuss with us, or if you have in general any questions regarding deep hole drilling technology. We'll be more than happy to help you through your in your applications. Okay, thank you so much.